Hello, this is a video on applying Doppler to MetaSound. So for those who use UE4 and use sound cues, you would have been used to seeing the availability of this Doppler node in the sound cue graph, which enables us to apply Doppler to any sound wave in the graph. And then moving over to MetaSounds, noticing that there's no Doppler node that we can use. I've seen a couple of solutions to applying Doppler, doing it based on the attenuation, but nothing that really fully satisfied the Doppler node in sound cues. So I wanted to look if there was a way that I could apply that to MetaSounds using blueprints. And what I come up with was this function for calculating Doppler that will either change the multiplier of the audio component or pass in semitones to the MetaSound and change the pitch by passing in that parameter. So what I've got here in the world is I've got an actor which is going to fly past me. It's playing a car sound. It's just a little sphere. You can imagine it's a car passing by, and I've got two versions of the sound. I've got one which is the sound cue and one which is a MetaSound. The sound cue uses a Doppler node. The MetaSound is going to use the function that I've set up here in the blueprint for it. And I'll compare those two now. So this first version, we're using the sound cue version of the car loop. And then the second time, we'll use the MetaSound version, which uses the Doppler function. So they both sound the same, and they both apply Doppler to the sound. So the blueprint version of the function is called on tick, but you could set this as a parameter coming out of the function. One of the benefits of this actually is, say if you've got a car, it's got an engine, it's got the wheels moving on the ground, it's got a horn, and you want to apply the same Doppler to all those sounds, you can just set it once rather than in a sound cue you'd use the Doppler node for each separate sound cue. So you can just calculate it once and then cache that value and pass it into whatever MetaSounds you need to apply Doppler to. So what I'll do is I'll go over this function now. I'll just fly over it, and then if you want to copy this function into your own project, you can do. So I'll just go over these slowly, and you can pause the video if you want to just have a look over how each section works. So all this is exactly the same as the code that's in the Doppler node in sound cues. So I've basically just copied out that code and put it in blueprints. The only extra things that aren't in the code is this clamp here, because I didn't want any negative values, and this extra bit of math at the end which will convert a multiplier into semitones. And the reason why I'm passing out a multiplier and semitones is because if this is applied to the audio components multiplier, it sounds very smooth. But if you pass it in as a parameter to a MetaSound, it can sound quite artifacty. So I can demonstrate that now by going to another actor that I've got set up. So what I've got here is an actor which is playing a 44 Hertz sine tone, and I'm going to fly past it, setting it as a multiplier in the audio component, and then I'm gonna play again flying past it by passing in the parameter to the MetaSound and changing the pitch based on that parameter, and you'll be able to hear the difference. So this is using the pitch multiplier in the audio component. So to smooth increase and decrease in pitch, if I pass it in as a parameter to the MetaSound using this pitch scale here, you'll be able to hear the artifacts. You can hear it kind of going down in pitch in steps. So I don't think that works as well, but using it as a multiplier works a bit better. It's only when the Doppler is quite extreme. If we take a look at the car version of it and we send in the Doppler calculation as a parameter and not a multiplier, you can see that this is unticked here. The change in pitch shouldn't be as noticeable and have as many artifacts as with the more extreme example. So let's have a listen to this one. So that one sounds a bit smoother than the extreme version did using the sine tone, and you can't hear the pitch changing in steps. So it is when you're using more extreme values and passing it in as a parameter that there's an issue. And that's it for the blueprint function. So one other thing I've done with this is I've enabled the function to take in a velocity rather than getting it from the actor itself. I am actually getting it from the actor here, but the reason I've done this is because if your actor doesn't have physics, then it won't have a velocity if it's moving, and this would just return 0, 0, 0 for its velocity. So I've made it a parameter, so if you need to calculate it in the actor itself, you can do, but if you have physics on the actor, this will work fine. So something else I've done is I've made a coded version of the function. Because there's a lot of math going on, I thought it would be wise to try coding it to see if that would increase the speed of it. So this is exactly the same as the blueprint version of it. And it's just a blueprint library function. And it's in a plugin. So I'll put the link to the GitHub repository for it. So if you want to use this function instead, we've got this variable here that needs to be passed in as a parameter and then set after that out parameter. That's the only additional thing you'll need to do for it. And then similarly with the blueprint version, you can pass this in as a multiplier, which is the calculated pitch out parameter. Then the return value would be the parameter that you pass into a MetaSound. I wanted to compare the blueprint function to the coded function. So this is a trace of the blueprint function. So if I grab a few frames here and go to calculate Doppler, you can see that the average time for the function here is 17.29 microseconds. Then if I compare that to the coded version, if I go ahead and grab a few frames here, and then go to the Doppler function, then you can see the average time of this is 2.13 microseconds. So there's actually a decent saving time-wise there. And that's it for the blueprint version of Doppler. I hope this helps you with your project.